Hello everyone, welcome to my third video in this series of going through the mock exam that was given to you in February. I will be going through video 3, questions 5 and question 6. As in the previous video, I will be going through the question in detail, highlighting the important key points, the common mistakes, and I will be also going through the marking scheme to show you what is expected of you when you're answering these questions, and how I would answer these questions to gain full marks. So question 5, as before, just to point out the additional information that I have included: motion and forces doing work. This is the topic that is being tested on in this question, and in green on the side is for each question under each of the marks available. I have highlighted the subtopics and the page numbers for the textbook that we use in school for the Edexcel Combined Science and the separate physics. So question 5. A student uses this apparatus to investigate the force needed to pull a block along a ramp. So you have the block here. There's a force of 26 newtons. Now, if you were to identify the apparatus, it would ideally be a Newton meter. Right. The length of the ramp when they're pulling it is 0.89 meters. The height of the ramp is 0.11 meter. Part A 1. State the formula linking work done, force and distance moved in the direction of the force. So either you can write a symbol equation or a word equation. In this case, I'm going to write a word equation. So the work done equals the force multiplied by the distance moved in the direction of the force. If you simply write force times distance moved, that should also give you the mark. I could write it as work done equals F times D, but I would recommend writing the word equation rather than the symbol equation. Part 2. The student pulls a block 0.89 meters along the ramp with a force of 26 Newton. Show that the work done by the 26 Newton force is about 23 joules. So work done is equals to the force multiplied by the distance moved. So the force is 26 multiplied by the distance moved is 0.89, which should give you an answer of 23.1 joules, right? Which is close to 23. Here you're proving that the answer that you get is close to that. That should give you the 2 marks. You need to show your work in for this because you're trying to show that the work done. You can't simply write it as 23.1 written. Should give you the mark, but we'll have a look at the marking scheme at the end of this question. Part B. The block has a mass of 1.3 kilograms and moves vertically upwards 0.11 meter. Calculate the increase in the gravitational potential energy. A lot of students get confused with when they say the increase in gravitational potential energy. You're simply calculating GPE. So the equation for gravitational potential energy, or GPE, equals mgh, which is mass, gravitational field strength, which is 10, and the height that is being used. So the mass is 1.3 kilogram multiplied by 10 multiplied by the height, which was 0.11. This should give you an answer of 1.4 joules. 1.4 joules. Part C. Most students managed to get the full marks for the previous two questions, and where they failed to get full marks was in this question, where you're trying to explain why the work done. So explain why the work done to move the block along the ramp is greater. Why is it greater than the increase in the GP store of the block? So looking at the answers, we find that to pull the block along the ramp, it takes 23.1 joules. But to just simply lift it up to the final point, it just takes 1.4 joules. In the next question, in part C, what they're asking is, why is it different? Why does it take more energy to just pull the block along the ramp rather than to just lift it? So let's have a look at the question again. Explain why the work done to move the block along the ramp is greater than the increase in the GP store of the block. Now, the main reason is when you pull the block along the ramp, there is friction along the ramp. So you are doing work against friction, and that's the main key idea that you need to tell in this answer. So let's start with that. Since work is done against friction when pulling the block along the ramp, so some energy is lost as thermal energy to the surroundings. So you're accounting for the loss in energy. That's why you're going that extra length to say what is happening to this energy, right? Whereas this is additional information, just you don't really need to say this. Whereas when lifting the block, work is done against gravity only. Now, that doesn't mean that you're not doing work against gravity here. You're doing work against gravity and friction. That's why there's two forces acting here, whereas here it's just gravity. So hence you use less energy of, what was the value here, 1.4 joules, and here you used 23.1 joules. Now let's have a look at the marking scheme. So what does the marking scheme say? So the equation that they're expecting is work done equals force times distance, or the full word equation, allow accepted symbols. So you can write a simple equation as well. And substitution and evaluation, you need to show the working, and 23.1 joules. And the third, evidence of recall of GP equals mgh. You can use 9.8 as the value for gravitational field strength, but here in GCSE we just simply use it as 10, which gives you 1.4 joules. Now for the last part, where most of you managed to get just 1 mark but failed to get the second mark for failing to indicate that work is done against friction, any reference to friction, air resistance, right? Energy transferred to the surroundings by mechanical work. So we mentioned that heat is transferred to the surroundings. Block not necessarily at constant speed, right? So we mainly covered these 2 points, which should give us the 2 marks. Now let's move on to the next question. Question number 6 is from June 2018 paper. This is from the Combined Science Higher paper, question 7, paper 2, high tier. And this question is on electricity and circuits. So question number 6, Figure 8 shows identical filament lamps connected together to a 12-volt power supply. Calculate the potential difference across each lamp. Now, potential difference is referring to the voltage across each lamp. So, what type of circuit is this? This is a series circuit. So, what happens to the voltage in a series circuit and the current as revision? So, the current is the same across all the bulbs. So, the same current flows through the entire circuit since it's the flow of electrons. So, there's no place for it to split up. But the voltage or the potential difference splits up or it's shared between the components. So, how do you work out the potential difference here? We have 1, 2, 3, 4, 5, 6, 7, 8 bulbs. So, there's 8 bulbs and we have a total potential difference of 12. So, 12 divided by 8 should give you 1.5 volts across each of those bulbs. Part 2 of question 6. The power output of each lamp is 0.75 watts. So the power is 0.75 watts. Calculate the resistance of each lamp, which is going to be R. So here it's a 4-mark question. So when you get a 4-mark question like this, ideally what involves is actually 2 equations for you to use. So let's write down the values. I find that writing down the values helps a lot. So what have they given us? Power is 0.75 watts, and we calculated above that the potential difference or the voltage across each lamp is 1.5 volts. Remember, they are asking you to calculate the resistance across each lamp, not all of them. And they are asking us to calculate the resistance, which is unknown, and we don't know the value of the current as well. So let's have a look at the available equation. The first equation that I would use is to calculate the current. So power equals the current multiplied by the voltage. P equals IV. Rearranging that equation, if I put these 3 symbols in the triangle, P, I, V, rearranging it, if I block off I, P is on the top and V is on the bottom. So I equals P over V. So 0.75 watts divided by 1.5 gives me 0.5 amps. Now I can use this value of the current in the second equation that I'm going to use. So the second equation that I'm going to use is V equals IR, which is Ohm's law equation. Again, putting that in a triangle, V on the top and I and R on the bottom. Rearranging it, R equals, or the resistance equals the voltage divided by the current. The voltage was 1.5 volts divided by the current, which is 0.5 amps, and that gives us a value of 3 ohms. A lot of students struggled to gain full marks on this question. Some of them did manage to get a part of the answer, but a lot of you were confused, mainly because you didn't realize that you had to use 2 equations and you were struggling to find the equation which links the appropriate values to get the answer. So remember, if it's usually a 4-mark question, it involves 2 equations, and there will be questions which involve these 2 questions. Let's move on to the next part of the 6-mark question. Part B, explain with the aid of a circuit diagram the method a student could use to investigate how the resistance of a single lamp changes with the potential difference across the lamp. So they are expecting you to draw a circuit diagram and then explain it as well. So let's start off with the circuit diagram. So as in any circuit diagram, you would start off by drawing the power supply first of all, right? So that's your power supply, and to the power supply you're going to connect an ammeter, which is going to measure the current in the circuit. Now, since you're trying to work out the resistance, how the resistance of a single lamp changes, you will need a lamp as well. So that's a symbol for the lamp. Changes with the potential difference across the lamp. How are you going to change the potential difference across the lamp? The best is to add a variable resistor, right? Now, once you add the variable resistor, how are you going to measure the voltage? Now, to measure the voltage, you will need a voltmeter, which should be connected across the bulb. Now, let's label this diagram. So, your power supply, variable resistor, lamp, voltmeter, and your ammeter. So how does this circuit actually work? By having a power supply, let's say you have 12 volts, you can use the variable resistor to change the voltage or the potential difference across the lamp. Remember, because the voltage is shared, this is a series circuit. When you change the voltage here, it will automatically change the voltage across this as well. So if you have 12 volts and if you make the voltage across the variable resistor 1 volt, the rest of the voltage should go to the lamp, which should be 11 volts. If you make that 2 volts, the voltage across this is going to be 10 volts, and if it's 3 volts here, the rest of the 9 volt goes here, and so on. So how do we answer the question? One of the easiest way to answer this question is to start off with this statement, which is to state the obvious, right? So set up circuit as shown in the diagram above, right? So this removes the need to actually explain how you're going to connect all of this. The second part, in order to measure the resistance, you need to use the equation V equals IR. So you can't directly measure the resistance, you are calculating the resistance. So rearranging that equation, remember V over I. So in order to calculate the resistance, you need the value of the voltage and the current here. So let's describe how we are going to measure the voltage and the current. Let me move the paper a little bit above so you can see, right? So measure the potential difference across the lamp from the voltmeter reading, right? The next part, measure the current in the lamp from the ammeter reading, right? Point 4, resistance across lamp equals V over I, right? So once you have calculated the resistance, what do you do? So because you want to see the change, how the resistance changes with the potential difference, you would say repeat for different values of potential difference and calculate the resistance. Now the rest of the information is just as notes that I'm going to write down. So if you were to record it in a table, what would the table look like? So I would have the voltage, the current, and the resistance. You can include this as part of your answer as well. It shows the examiner that you have a deeper understanding of what you're trying to say. So 0, 1, 2, 3, 4, 5, 6 volts. 6 values is more than enough for you to give a pattern, right? And if you were to draw the graph from this, the shape of the graph is going to be like that. Now if you go and measure the negative values, it should actually look like this. Voltage is going to be on the x-axis and current is going to be on the y-axis. Now what are the variables in this experiment? The independent variable is the voltage that you are changing. Voltage or the potential difference, right? The dependent variable is the current, but indirectly it affects the resistance which you are actually working out. And the control variable is going to be your lamp that you use. So you don't want to use change the lamp because that affects the resistance across the lamp. Let's have a look at the marking scheme. So what does the marking scheme say? For question 6 part A, it was 1.5 volts, and for part 2, here I've split it into two. I've written down the equation. For the first part, you're trying to calculate the current, which we are using the equation P equals IV. Rearranging it, it will give you 0.5, and then use the second equation V equals IR will give you 3 ohms. Now for those who are doing higher tier maths, this is an interesting way of actually doing it. You can actually combine two equations into one because you have a common value of the current in both equations, and you can actually combine those two equations, and if you do combine it, you would get the equation P equals V squared over R, and it still give you the same marks. Now it's not necessary, but this is the most straightforward way. The second part, or the 6-mark question marking scheme. So what is the marking scheme for the 6-mark question? Answers will be credited according to the candidate's deployment of knowledge and understanding of the material in relation to the qualities and skills outlined in the generic marking scheme. So in the circuit diagram, you are expected to label all of this or draw all of this. Power supply, ammeter, voltmeter, filament lamp, means of varying the potential difference, which was our variable resistor. So we had all of those in our series circuit that we drew. Description of the method. Measure current with ammeter. So you are pointing out that you are measuring the current with the ammeter. Measure potential difference with the voltmeter. Vary the potential difference. Calculate the resistance. Repeat and compare, which we did all of them. So looking at the level. So when we are, as examiners, when we are marking questions, what we do is actually read the entire question. We don't give it point for marks for each section. We read the entire question and then decide, is this question going to be level 1, 2 or 3, and then decide if it's level 2 question. If we think it's a level 2 question, it's a matter of deciding, are you going to get 3 or 4 marks. Now let's have a look at level 3, because this is where we are aiming. We want our answer to be somewhere between 5 and 6 marks. To get anything between 5 and 6 marks, an explanation that demonstrates accurate and relevant physics understanding throughout, understanding of the scientific ideas, inquiry, techniques and procedures is detailed and fully developed. Presents an explanation that has a well-developed structure, which is clear, coherent and logical. This is where some students actually fail to get that 6 mark. They would have actually have all the points, but this is why I insist that writing 6-mark questions, write it in steps, write it in bullet points. That way it is much more clear and concise, and it's well-developed answer, and you're not going to get it wrong. Make sure that you spend more time thinking what you're going to write rather than just simply writing it and then thinking halfway through. That way your answer is going to be much more clear and to the point, and you should get those full marks. Right. this brings us to the end of our mock exam, going through the questions for the mock exam for the combined science. The next two videos is going to be for the higher tier physics, separate physics paper. I will see you there.